Hello students, today we are dealing with a new topic, that is block diagram reduction technique. In the previous class we have discussed about block diagrams to represent the control systems, and the block diagram can be reduced to find the overall transfer function of the system, and some rules are used for block diagram reductions, and we can go through the rules. And first of all, and rule number 1 is combining the blocks in cascade, and here we are representing the system with two gains, that is G1 and G2. If the system has two gains G1 and G2, and then how can we combine these two blocks? And when we are combining these two blocks, the overall gain will be G1 G2, and its input will be A and output will be A into G1 into G2. See, in the first rule, first block is G1 and the input to that block is A, and the output of first block is AG1, and that AG1 goes to second block G2, and the output of second block will be AG1 into G2. That means if we are giving an input to a system, the output will be the multiplication of input and the system gain, okay? Or that means we can cascade these two blocks into single block, and that will have a gain G1 into G2. So what is the importance is that if in a system, if in a control system, if you are given two blocks, you can combine these two blocks by changing the gain as multiplication of the two gains. That means the gain will be G1 into G2. And the second rule is combining parallel blocks or combining feed forward path. And here in the figure there are two paths, and these two paths are parallel. See, first of all, input is A, and input directly goes to G2, and also input goes to G1. The output of each block will be AG1 and AG2. And next section is a summer, where we are summing these two outputs. So the output of the summer will be AG1 plus AG2, and A is common and it can be taken outside, so it will become A into G1 plus G2. So this is the block, and here the blocks are parallel, okay? And next we have to combine these blocks. So we can represent the block as A is the input, and block overall transfer function will be, overall gain will be G1 plus G2. So the output will be A into G1 plus G2. See, so if you are given two blocks which are connected in parallel, then you can change that block into a single block, and its transfer function will be, or gain will be, G1 plus G2. Okay, these two cases, when the blocks are connected in series, its overall transfer function or gain will be G1 G2. If they are connected in parallel, their overall transfer function will be equal to G1 plus G2. Okay, that's the thing. And next is the third rule, and in that rule, moving the branch point ahead of the block. Here there is a block and which is having a gain or transfer function as G, and there is a branch point before that block. Okay, branch point is shown, that is A directly go to G, and there is a branch point and which gives the A itself. So the output is AG and A, and we can, what our requirement is, branch point should be moved ahead of the block. So the branch point will be after the gain block G, but we should get the same result as in the previous case. Okay, our result should be AG and A. So we have to change the transfer function of that block. So A is directly go to G, so we will get the output as AG. One of our output is same. And next we will have A. So in order to get A, after the block G, we have AG, and but what we need, what is our need is, we should get A. So we have to incorporate a 1 by G block there. Okay, so in order to move the branch point ahead of the block diagram will change like this. Okay, so A will directly go to G, and the branch point will be moving after G, and its output should be given to 1 by G block. Okay, and next rule is moving the branch point before the block. So in the diagram, the branch point is after the block G. That means A is given to G, and after the G there is a branch point, so that output is AG and AG. Okay, in the first line there is AG and in the last line also AG, but our requirement is we have to move the branch point before the block. Okay, so it will come before G. So once it comes to before G, we need the output AG and AG itself. So we have to change the gain. So in order to get AG and AG, we have to give G and G separately to in each path. Okay, so if we are moving the branch point before the block, we have to incorporate a gain block in each path, each parallel path. Okay, so in order to move the branch point ahead of the block, we have to incorporate a 1 by G gain in one of the path. Okay, and this is the rule. And the next rule is moving the summing point ahead of the block. Here the third case, fifth case is moving the summing point ahead of the block. In that case, here summing point is before the gain block G, and here it is shown that A and B are given to that summing point. So the output of summing point is A plus B, and this A plus B goes to gain G, and the output of the block will be A plus B into G. So in the next case, we are moving the summing point after the block. Okay, so we should have make some changes in the gain block, and in order to get the same result, that is A plus B into G. So we should have give separate gain block in each path, that is A given to G and B given to G, so that we will get AG and BG in the two parallel path, and these two are given to a summer, and the result of the summer will be A plus B into G. So in order to moving the summing point ahead of the block, that is after summing point after the block, we have to incorporate two gain blocks in each path, and then it will goes to summing point. Okay, so that's the fifth rule, and you should by heart all these rules. The rules will be easier when you understand the concept. Okay, if the concept is clear to you, then it will be very easy. There is no need to by heart it. Okay, and the next rule is moving the summing point before the block. So the block is given, A is given to G, and after that block there is a summing point. So AG is going to one end and B is the other input. So output of the summer will be AG plus B. And we have to move that summing point before the block. And we are moving the summing point before the block, but the output should be the same. So we have to make changes in the gain values. So summing point will be come before the gain block G. So that A is given to that summing point, and B is given to a block which I am gain 1 by G. So B by G we will be getting B by G, and the output of the summer will be A plus B by G, and then it is given to gain block G, so that the result will be AG plus B. Okay, so when we are moving the summing point before the block, we have to incorporate a 1 by G block in one of the branch. Okay, 1 by G block 1 by G block after the input B. Okay, and the next is interchanging the summing point, and here the summing point is given, and A and B are given to the summing point, and the output of the summing point is A plus B. Then it is given to another summer, and C is given to the negative part of the summing point. So these three will be subtracted, that is A plus B. C will be subtracted from A plus B, so output is A plus B minus C. So interchanging summing point means that we will interchange the input. So in order to get that, we can change the inputs as A and C is given to first summing point, and C is given at the negative part. So output will be A minus C, and then this A minus C is given to another summer, and B is also given to that summer. So the output will be A minus C plus B. So what you should remember, you should remind in mind that once you are changing any of the part of the block diagram, the result will be same. Here, if we are moving the summing point before the block or after the block, the result should be the same. That is the main concern, okay? And next is the interchanging summing point we have discussed, and next is the 8th rule, that is splitting summing point. And here 3 inputs A, B and C are given to the summer, and A and B are given to the positive terminal and C is given to the negative terminal, so that the output of the summer will be A plus B minus C. And if we are splitting this summing point, we can split it by 2, that is we are using 2 summers, and in the first summer A and B are added and its result will be A plus B. And in the next case we will give the C input to the negative terminal of the second summer, so that we will get A plus B minus C. And these summing point rules are simple, okay? Next is rule 9, and in the case of rule 9 we are combining the summing points. Here there are 2 summing points, and in the first summer A and B are given, so the output is A plus B, and again C is given to the negative terminal of the second summer, so that output is A plus B minus C. And we can combine these summers, and we can replace 2 summers by a single summer, so that the resulting diagram will be a one summer having A, B and C inputs, and C is given at the negative terminal, so A plus B, output will be A plus B minus C. And next is elimination of the negative. 10th rule is elimination of the negative feedback loop. So here is the block diagram, and this block diagram consists of a summer, forward path gain G, and a feedback path gain H. And in the summer we are giving the input as R, and there is a G in the forward path, that is open loop gain G, and the feedback path contains the gain H, and G receives R minus CH, because CH is the term that is coming to the negative terminal of the summer, so R and CH will be subtracted, R minus CH will be obtained at the output of the summer, and this R minus CH will be multiplied with G, so we will get R minus CH into G at the output, and the output is C, and so C is given to the feedback path, so we will get a CH in the negative terminal of the summer. And this is the feedback loop, and we have to change this feedback loop by a single gain, so that output circuit will contain a single block with the gain G by 1 plus GH. We have the proof for this gain, that we know that output C is equal to R minus CH into G from the diagram, okay? And C is equal to, if we are multiplying each term, then we will get RG minus CHG. In this, CHG term can be CHG term goes to left side, so we will get a C plus CHG equal to RG. And in that, C can be taken outside, so C into 1 plus HG equal to RG, and C by R will be equal to G by 1 plus GH. So the transfer function will be G by 1 plus GH. So we can replace this block diagram with a feedback loop by a single block having gain or transfer function G by 1 plus GH. And next is elimination of positive feedback, and actually this is the negative feedback. We discussed about the negative feedback. In that case gain will be G by 1 plus GH. Next we will discuss about the elimination of positive feedback loop. So R is given to the summer, and there is G, and in the feedback path there is H, and H is given to positive terminal, so output will be C, and we can eliminate the positive feedback loop, and we can represent this system with a single block, and its gain or transfer function will be G by 1 minus GH. In the previous case it is G by 1 plus GH. In this case it is G by 1 minus GH. Since when the feedback path goes to a positive terminal, then it will be G by 1 minus GH. If it is going to, if the feedback loop again going to negative terminal, it will be G by 1 plus GH. And these are the 11 rules corresponding to the block diagram reduction, and you all should understand these rules, then only you can do problem. Okay, you should understand the rules and you should by heart the rules, then it will be easier for you to solve the problem. Okay, and these are the 11 rules for block diagram reduction, and next we can discuss these rules with the help of a problem. And the question is that reduce the block diagram shown in the figure 1 and find the gain C by R. So we have to find out C by R, that is transfer function we have to find out. So it is given R is the input, C is the output, and C by R is the transfer function. Okay, output divided by input is the transfer function. So look at the circuit. You know that it contains different paths and different summers and different blocks, and there are feedback path also. How many feedback paths are there in the question? There is only one feedback path, right? G1. H contains a feedback loop. Okay. So first of all we should know where we have to start. ഓക്കെ, അപ്പം നമ്മൾക്ക് ഒരു പ്രോബ്ലം കാണുമ്പോൾ അത് എവിടെ നിന്ന് തുടങ്ങണമെന്ന് മനസ്സിലാക്കണം നമ്മൾ. അപ്പോൾ ഇൻ ദിസ് കേസ് എവിടെയെങ്കിലും ഈ പ്രോബ്ലം സോൾവ് ചെയ്യാൻ പറ്റുമോ, അല്ലെങ്കിൽ നമുക്ക് മുന്നേ കണ്ട ബ്ലോക്ക് ഡയഗ്രം റിഡക്ഷൻ ടെക്നിക്കിൻ്റെ റൂൾ അപ്ലൈ ചെയ്യാൻ പറ്റുമെന്ന് നോക്കണം. ഓക്കെ, ഇവിടെ G1ഉം Hഉം കൂടി ഒരു ലൂപ്പ് ഫോം ചെയ്യുന്നുണ്ട്. കറക്റ്റ്, നമുക്കതിനെ വേണമെങ്കിൽ സോൾവ് ചെയ്യായിരുന്നു ഒരു റൂൾ വെച്ചിട്ട്. എന്താണ് നെഗറ്റീവ് ഫീഡ്ബാക്ക് ഉള്ളൊരു ലൂപ്പിൻ്റെ റൂൾ എന്തായിരുന്നു? ഇവിടെ നെഗറ്റീവ് ഫീഡ്ബാക്ക് ഉള്ള ലൂപ്പിൻ്റെ റൂൾ എന്താണ്? G/1 + GH. പക്ഷേ അതിനിടയിൽ ഒന്നും വരാൻ പാടില്ല അല്ലേ. R കൊടുത്തു, G വന്നു, H ഫീഡ്ബാക്ക് പാത്തിൽ വന്നു, പക്ഷേ ജീൻ്റെ പുറകിലൊന്നും ഉണ്ടാകാൻ പാടില്ല അല്ലേ. അത് കംപ്ലീറ്റ്ലി ഫ്രീ ആയിരിക്കണം, ഇതിനിടയിലൊന്നും വേറെ ബ്രാഞ്ചസ് ഒന്നും വരാൻ പാടില്ല. പക്ഷേ ഈ ക്വസ്റ്റ്യനിൽ എന്തുണ്ട്? G1ൻ്റെ പുറകിൽ ഒരു ലൈന് പോകുന്നുണ്ട് അല്ലേ, G3 എന്ന് പറയുന്നത്. ഇപ്പോൾ അത് അവിടെ ഇല്ലായിരുന്നെങ്കിൽ നമുക്ക് എളുപ്പത്തിൽ ഇതിനെ മാറ്റാമായിരുന്നു അല്ലേ. ഓക്കെ, ഗോട്ട് ദി കോൺസെപ്റ്റ്. ഇഫ് ദർ ഈസ് നോ branch point in the line that is connecting the summing point and G1, first summer and G1, you can solve easily. So first step is we have to move the branch point from first summing point path to the place after G1. Okay, so first step is move the branch point ahead of the block G1. Okay, that is the thing. Move the branch point ahead of the block G1. So that is shown by dotted line. Okay, if that point is changed to the new place, you can solve it easily. Okay, so you should remember the rule for changing the branch point ahead of a block. So you can go to the rule. So this is the rule, moving the branch point ahead of the block. This is the rule. See, moving the branch point ahead of the block. Here, if that branching point is moving ahead of the block G, then in that path there will be 1/G. Another block that containing 1/G gain will be there. So similarly you can apply this rule here. In this question you can apply that rule. Okay, so if you are moving the branch point after G1, so the G3 path will be modified as it will contain a block 1/G1. Okay, so you got the idea. അതായത് G1ൻ്റെ പുറകിലായിരുന്നു ബ്രാഞ്ച് പോയിൻ്റ് ഉള്ളത്, പക്ഷേ അത് G1ൻ്റെ മുന്നിലായിരുന്നു വന്നതെങ്കിൽ നിങ്ങൾക്ക് G1ഉം Hഉം കൂടി സോൾവ് ചെയ്യാൻ പറ്റുമായിരുന്നു ബൈ യൂസിങ് ദി ഇക്വേഷൻ G1/1 + GH ബ്ലോക്ക്. ഓക്കെ, പക്ഷേ ഇവിടെ ബ്രാഞ്ച് പോയിൻ്റ് G1ന് മുന്നേ വന്നു. അപ്പം നമുക്ക് സോൾവ് ചെയ്യാൻ വേണ്ടിയിട്ട് നമ്മൾ എന്ത് ചെയ്യാന്ന് വെച്ച് കഴിഞ്ഞാൽ ഈ ബ്രാഞ്ച് പോയിൻ്റ് G1ന് ശേഷം വരുത്തുകയാണ് ചെയ്യുന്നത്. അതാണ് ഈ ഡോട്ടഡ് ലൈൻസിൽ കാണിച്ചിരിക്കുന്നത്. G1ന് ശേഷം വരുത്തുന്നു. അപ്പോൾ G1ന് ശേഷം വെറുതെ അങ്ങ് വരുത്താൻ പറ്റില്ല, അതിന് ഒരു റൂൾ ഉണ്ട്. എന്താണ്? ബ്രാഞ്ച് പോയിൻ്റ്, മൂവിങ് ദി ബ്രാഞ്ച് പോയിൻ്റ് എഹെഡ് ഓഫ് ദി ബ്ലോക്ക് ആക്കുമ്പോൾ G1ന് മുന്നേയുള്ളൊരു ബ്രാഞ്ച് പോയിൻ്റ് G1ന് ശേഷമാക്കുമ്പോൾ ആ ബ്രാഞ്ചിലേക്ക് എന്ത് കൂടി വരും? 1/G1 എന്നുള്ളൊരു ടേം വരും. ഓക്കെ, G1ന് മുന്നേ ഉള്ള ഒരു ബ്രാഞ്ച് പോയിന്റ് G1ന് ശേഷമാക്കുമ്പോൾ ആ ബ്രാഞ്ചിൽ എന്ത് വരും? 1/G1 വരും. ദാറ്റ് മീൻസ് G3ൻ്റെ അടുത്ത് തന്നെ എന്തൊരു ബ്ലോക്കും കൂടി വരും? 1/G1 വിൽ കം. ഓക്കെ, that is the thing. So we can draw the diagram like this. Other part of the circuit is same as before in the question, and we will move the branch point after G1. And so if we are moving like this, we have to incorporate a 1/G1 block in that path. Okay, so it is shown in the inside the dotted line that 1/G1 is in series with the G3. Okay, all other portions will be remain same. Okay, see in this figure, if we are changing that point to in between G1 and G2, G3 path will contain a block 1/G1. Okay, so we can easily solve G1 and H together. So the rest of the circuit will be the same. G3 will be connected to the second summer and G2 also connected to the second summer. You can see the rest of the part will have no change. That is, R is there, G1 is there, H1 is there, and that branching point will start after G1, and so that there will be a extra block 1/G1 in the forward path in series with that will be in series with G3, and G3 will goes to the summer, posterior terminal of the second summer, and G2 also will be going to the posterior terminal of the second summer. So this diagram will be familiar to you and it will be easy for you to solve. Okay, you know that in the first dotted box you can see G1 and H1 are parallel, and H1 is a feedback path and it goes to negative terminal of the summer, and you know the rules for reducing this type of block. Negative feedback path can be reduced by replacing the equation G1 divided by 1 plus G1 into H. You have the rule. What is the rule? The rule is rule number 10. By rule number 10, we can eliminate the feedback loop. Okay, rule number 10 you should remember. So the diagram will look like this. The seconds in the step 3, R goes to a single block which have a gain G or transfer function G1 by 1 plus G1 into H, and this G1 by 1 plus G1 into H is obtained by solving or reducing the first block in the dotted line. Okay, inside the blocks inside the first dotted line. Okay, so next we can solve the next we can look at the dotted lines in the upcoming branch. That is, inside the second dotted line there are blocks 1/G1 and G3. These are connected in series. When two blocks are connected in series, they can be multiplied together to get the total gain or total transfer function. So that is by rule number 1. Okay, rule number 1, you can see what is rule number 1. Rule number 1, G1 and G2 are connected in series, then it can be replaced by a single block and whose gain is G1 into G2. So A is going to G1 into G2 and output will A G1 G2. So we can apply rule 1 to the second box. Okay, let us go to the problem. When we are applying the rule 1 to second block, we will get 1/G1 into G3 will be G3 by G1. Rest of the part will be the same. And also next in this diagram, in the step 3, we can also solve the second, the dotted box. Okay, and it is seen that this is a connection similar to parallel branches. Okay, when two blocks are in parallel, we can solve it by adding those blocks. See, this diagram is similar to the diagram which is shown in the rule number 2. In the rule number 2, two blocks are connected in parallel and its output is going to the summer, and where both are added, so these connections are parallel. In the case of parallel blocks, we can combine it to parallel blocks or combining feed forward path, we will get the transfer function G1 plus G2. So we can apply rule number 2. Okay, so we can apply rule number 2 to solve this dotted line, the blocks inside this dotted line. Okay, so you can see that these two blocks are parallel and these are feed forward path, because the direction is marked as in the forward direction and both the blocks comes in the forward path, and also they are added in the summer, so we can say that these are parallel. In the case of parallel blocks, we can add the transfer function. So G2 is added with G3 plus G2 is added with G3 by G1. So we can redraw the blocks like this. In this step for combining blocks in cascade, we will get R will be there. First block is saying G1 by 1 plus G1 into H, and second block can be G2 plus G2 by G3 by G1, and output is C. And in this case, two blocks are connected in series. When two blocks are connected in series, we can apply first rule. That means the transfer function will be multiplied. So we will get G1 by 1 plus G1 into H into G2 plus G3 by G1. So both the transfer functions are multiplied. So G1 divided by 1 plus G1 into H into G1 G2 plus G3 by G1, that is a transfer function. So the final result is G1 G2 plus G3 by 1 plus G1 into H. This is simple mathematics, and you should know how to solve the blocks, and you should know how to apply the block diagram reduction techniques in order to solve the question. Okay. So we can write the overall transfer function of the system is C by R is equal to G1 G2 plus G3 by 1 plus G1 into H. This is all about this question. You can go through it again, then you will get an idea. And first of all, you should remember the rules, then only you can apply it to the reduction process, and you should know where at what point where we have to use some rules. Then only you can solve the problem. You can change the branch point to some other points in order for the easier solution of the problem, in order to get an easy solution to of that problem. So that's all about this topic, block diagram reduction technique, and let us meet with another question. Bye.